Okay. Lesson or notes 13. We are comparing functions. It's called day 1, doesn't matter. All right, here we go. Example 1. 3 trains, A, B, and C, leave a train station at the same time. The graph shows the relationship between time and the distance for train A. So this is train A. This is train B, and this is train C. Another typical state question, comparing graphs, equations, and charts. So, number 1 says, what is the slope of the graph? So let's just look at this graph. It's starting at 0, 0, and unfortunately, guys, it's can't see very well. I believe at 2, it's right here, and that is at 60. So at 2 hours, it was 60 miles away. So 1 hour, it would be at 30. So the slope here, the m is 30 miles per hour, right? For graph 1. So your m in this one, m is 30, okay? What does the slope represent? In question number 2 is that train A rate equals 30 miles per hour. Got it? Number 2, the relationship between time and distance for train B is given in the equation. So the equation was y equals 45 times x. What do you think the slope is? It's 45. So m here is 45, which means that is 45 miles per hour. So this is train B. His rate of change is 45 miles per hour, so it's quicker. Which train is moving faster, A or B? B. Okay, his slope is larger. Okay, therefore he's faster. The time-distance relationship for train C is shown in the table. What is the ratio of distance to time? Distance to time, distance to time. So basically we need to find the slope here. 3, 6, 9, 12. So we're counting up by 3, right? Remember, change in y over change in x. 105, 210, to 315, to 420. Okay, so if we just subtract 210 minus 105, what do we get? We get what? I can't think here. 105, right? 105. Is it going by 105? So 210 plus 105, yep, is 315. 315 plus 105, so this is all going up by 105. So the change in y is 105, and the change in x is 3. Okay, so now if I divide 105 divided by 3, I believe it goes 35. So technically, the slope here is 35 miles per hour. Okay? All right, so we have the 3 of them. Okay. The time distance ratio for train C is shown in the table above. What is that ratio? And we just figured it out. It was 105 in 3 hours, which comes out to be 35 miles per hour. Compare the speed of train C to the speeds of A and B. So we got a 30-mile-an-hour train, we got a 45-mile-an-hour train, and we got a 35. So train C is in the middle, right? So train C is faster than who? Faster than train A, but slower than train train B. Easy enough. Doesn't take a genius to figure that out. All right. Next page. Okay, the equation, there we go. We see it. The equation y equals 11x represents the calories Jake burns when cross-country skiing, where x is time in minutes and y is the total number of calories. The graph shows the calories he burns while playing basketball. Which activity burns calories at a faster rate? Okay, so if this is him skiing, y equals 11x for the skiing. All right, so basically it's 11. Let's figure out what this guy in basketball, what's it doing? And that's minutes. Is this minutes? Ooh, this is a tricky one. Because this is in hours, in 1 hour, in 2 hours. Oh, this is a terrible graph again. In 2 hours, we're probably at somewhere, it's probably 1,500, right? Because 1 looks like it's under, so I can't really tell. So let's go 1,500 divided by 2. Change in y over change in x. So y is 1,500. So it's y divided by x, remember? Okay, so that comes out to be about 750. And this is calories per hour. Okay, so if this guy does 11 in minutes, 11 per minute, then how many minutes are in an hour? We got 60. So wouldn't it be 60 times 11? Right? It was 11. Wait, 11 represents the calories Jake burns when cross country, where x is time in minutes and y is number of calories. The graph shows he wasn't playing basketball. So, well, let's do it. So 60 times 11, isn't that 660? 660 calories. So which one does he burn the most at? Basketball. Burns more calories. Okay? And the doggies wake up. Someone's home. Okay, let's try this one. A bowling alley offers different birthday packages. We have package A is represented by this, where C is the total cost and P is the number of people. Okay, so they're charging $7 per person, but $5 to start. Package B is in this table over here. So we got to figure out what this means. 1, 2, 3, 4. Okay. So how did this increase? So from $12.50 to $19, it was increasing by $6.50. And from $19 to $25.50, that is another $6.50. And another $6.50, right? So we know it's going by $6.50. So if we back it up, take $6.50 away from $12.50, take away $6.50, we land at, right, $6. So for 0, it would be 6. Okay, so the equation for this over here, for this package, the cost comes out to be $6.50 per person, but plus the initial fee was $6. So if to compare the two, C equals 7P plus 5, or C equals 650 P plus 6. If 12 people attend the party, which package will cost the less? So now we substitute 12. C equals 7 times 12 plus 5, or C equals 650 times 12 plus 6. 84 plus 5, this would be $89. And over here, 650 times 12 is 78 plus 6 comes out to be $84. So package B. B is cheaper. Okay. Comparing functions, finding the function rule for A, find the function rule for B, find the function rule for C. Try it on your own, and then plot each of those points down here and write the equation for each.